Hello everybody. Now the new topic is refractive index. See, we have seen what? Laws of refraction. In laws of refraction we have seen what? When light ray passes from one rarer medium to another denser medium, then it slightly changes direction. Okay, in your language we said it slightly bends. Now the question is how much bends? It depends on the density of medium. Which rarer medium is which type of medium and denser is which type of medium. It depends on what? Density of medium. So this depending density and its ratio of light ray, velocity of light ray, when it passes from one medium to another medium, this ratio is known as what? Refractive index. We have seen in laws of refraction that refractive index, it is denoted as eta. You have to extend the ends of the n, denoted as n and known as eta. Okay. Now refractive index, eta means what? It is the speed or velocity of light in medium 1 with respect to speed of light in medium 2. See, you have to write this thing. Definition is very simple, that what is called refractive index, it is the ratio of speed of light in medium 1 to the speed of light in medium 2, or velocity of light in medium 1 to the velocity of light in medium 2. If it is velocity, I can write v1 upon v2, medium 1 upon medium 2, velocity denoted as v. So eta equals to v1 upon v2. It should be written as not only eta, it is called eta 21. What do you mean by eta 21, not 12? Eta 21 means what? You have to say eta 21. Here eta means what? Refractive index. So say refractive index of medium 2 with respect to medium 1, that is called eta 21. Refractive index of medium 2 with respect to medium 1, that is called eta 21. According to the laws of refraction, we say that eta 21 equals to eta 2 upon eta 1. That is, refractive index of medium 2 with respect to medium 1 is refractive index of medium 2 with respect to medium 1 ratio, and it is called sine theta 1 upon sine theta 2. Sine theta 1 upon sine theta 2 is always constant. This constant is known as Snell's law. Scientist Snell's gave this, so it is known as Snell's law. If you cross multiply this and this, then eta 1 sine theta 1, that is equal to, multiplied here, eta 2 sine theta 2. This is the generalized form of Snell's law. Is it okay? So we can say that if it is eta 21, you have to write eta 2 upon eta 1, and in the language of sine or angle, theta 1 upon theta 2. Don't write theta 2 upon theta 1 because angle changes. Is it okay? Now another word, it is about refractive index, which we compare with velocity of light in vacuum, which is known as absolute refractive index. Absolute refractive index is also denoted as eta, but absolute refractive index is the ratio of velocity or speed of light in vacuum to the velocity or speed of light in any medium. if velocity of light in vacuum is denoted as c and velocity of light in a medium is denoted as v, then it is called c upon v. If medium 1, then v1, medium 2, then v2. So absolute refractive index is the ratio of velocity of light in vacuum to the velocity of light in medium. Remember one thing, that velocity of light in vacuum is the highest than in any other medium. Okay, it means that numerator here, velocity of light in vacuum is highest 3 into 10 raised to 8 meter per second. This is the highest velocity in vacuum. When it enters into air, then because of the friction, velocity slightly, very slightly decreases. When it enters into the water, then again velocity decreases. When it enters into the glass slab, again velocity decreases. It means what? If density of the medium increases, means medium becomes highly dense, then velocity of light decreases. Okay, remember this thing, velocity of light decreases when density of the medium increases. Okay, so velocity of light in vacuum is highest than any other medium including air. So we can say that according to maths, we can say what? The numerator of this ratio is always bigger than that of the denominator. If numerator is bigger, you can say that absolute refractive index of any medium is always greater than 1. If numerator is more than that of the denominator, then the division is always greater than 1. This is the one line objective, that absolute refractive index of any medium is always greater than 1. True or false? So it is true. Is it okay? Remember one thing also that I told you just before this, that velocity of light is the highest because vacuum has very negligible density. So if density of medium increases, velocity of light decreases. As for example, if you said that refractive index of diamond is 2.42, highest refractive index of any material or medium is the diamond. Refractive index of diamond is 2.42. It means what? The ratio of velocity or speed of light in diamond with respect to any other medium, that is suppose air, is 2.42. Ratio of velocity of light in diamond to the velocity of light in any medium, this ratio is 2.42. Similarly, you can say that refractive index of air is 1.004, approximately we take it 1. Refractive index of glass is 1.33. Okay, you have to remember this 3 only. In your textbook the total table is given, but the total table is not to remember, not to learn. You have to learn only this 3, that diamond's refractive index is the highest than any other and air refractive index is least, okay, in terms of medium. Now refractive index also vary with the color also. If it vary with the color, we said that it depends on wavelength of that color. Means refractive index of violet color is greater than the refractive index of red color, because violet color wavelength is least and red color wavelength is most. That means if wavelength of the color decreases, refractive index increases. If wavelength of the color decreases, then refractive index increases, and the vice versa. If wavelength of the color decreases, wavelength increases, then decreases. Is it okay? So this is about refractive index. Now we are going to learn about this generalized form of Snell's law with the help of rectangular glass slab. 3 marks, important question. That's it for this.